So welcome to the Big Data and Machine Learning and E-commerce panel. Just quick show of hands, how many folks here work in e-commerce? A few. Well, that's actually good because the themes that we'll be talking about are pretty broad. We'd like to keep this interactive, so if you have a question for our panelists, you can just tweet me at Sam Charrington, and you'll find that on the speaker list, and we'll try to incorporate your questions. But I'd like to start off with introductions. Again, I'm Sam Charrington, principal analyst with Cloud Pulse Strategies, and my interests are in the technologies that enable people to deliver more intelligent applications. And our panelists.
Hey, I'm Lina Weichbrot. I work at Zalando as a data scientist. And yeah, we do the usual data science stuff. So we work a lot with different algorithms. We do the prototypes before they make it to the site, a lot of testing. And privately, I also am a big Linux enthusiast.
Okay, hi. So I'm Cédric Archambault. I'm a senior machine learning scientist at Amazon. So I'm based here in Berlin. I'm leading the algorithms team here, and so our mandate is to democratize ML. So that's related to one of the previous talks, both internally and externally. So that means that we would like people to abstract away about the infrastructure, people to abstract away from actually algorithms. So what matters is the problem they would like to solve. So whether it's classification or regression problem, for example, but they don't have to worry about the algorithm, and they don't have to worry about like the parameters to optimize. So we try to automate that process as much as possible, and so people can focus on solving their application instead of tweaking the algorithm.
All right, great. Can we start off by talking about how data science is organized in your companies?
Okay, so it used to be Amazon is very vertical, organized in a vertical way. So teams are focusing on one specific product, customer focused, and then there are some needs about data science in those contexts. So you had like data scientists or machine learning people a bit like scattered all over the company, and more recently there was an effort to consolidate that. So I'm part of what we call the machine learning core team, which is distributed according there's a team here in Berlin, in Seattle, and in Bangalore, and so we work with it's more horizontal and work with different business teams across the company.
Lena?
Okay. For Zalando, it's a little bit the other way around. We used to be one central unit of data scientists. So right now we have more than 60. But now we're moving a little bit away from that to bridge that gap easier between having things as a prototype and bringing them into production. That's why a lot of the teams actually now have 1, 2, how many ever they need data scientists. So ranging from fraud to logistics, all kinds of applications, and actually text analytics and a lot of stuff that's based on natural language processing is actually in Dublin. That's a little bit of a special case. Yes.
Right. So I think personalization and recommender systems are pretty much table stakes at e-commerce companies, thanks in no small part to Amazon. And so I'm wondering if we can spend some time talking about other things that you're doing and maybe even things that might surprise us. Where are you applying predictive analytics, machine learning within the business? Lena, why don't you start us?
Actually, there's many areas where you can obviously apply machine learning, and I think most of the people in the room know that there's really big chances, opportunities in different areas. So it's ranging from logistics to just name an example. Some of our guys, we have this route, so you order something we are a fashion retailer, so some of you might not know, so you order a package and then the guy, you maybe order some items like a sweater, a trouser, something, so the order arrives at the warehouse and then the guy has to pick this stuff off the shelves, and actually we try to optimize where you put them, so that's one analytical problem, but you also have to optimize the way that those people walk in order so once that they don't have to walk a very long time, but also that they're faster. So for example, route optimization, that's some of the stuff that we do, to just name one. But a lot of the problems, you name it, you can often apply data science to it to make it, find a good solution.
Right. Cedric?
Yeah, so in fact, the range of problems that we apply machine learning is very broad. So people think about Amazon about retail, and of course there are like recommendation engines. But the customers that we have, this one chunk is those active accounts, retail accounts, but then there are like a second part is a second series of customers that are sellers. So what people don't really realize is that more than 40% of what is sold on Amazon is not sold by Amazon. Like a fourth set of customers are content creators. So it's like Amazon Instant Video, like Amazon Series. So for example, one of the latest Amazon original series, like Transparent, won a Golden Globe. It's one of the first time a streaming series won a Golden Globe. And then, of course, there are developers. So Amazon Web Services is the fastest growing segment. And it's like about more than 1 million accounts right now. So that's a big set of customers. So the range of customers is pretty broad, and the range of applications of machine learning and data science is also, because of that, very broad. So, for example, we apply machine learning in fulfillment centers, in warehouses, where, so a couple of, like I think 2 years ago, Amazon bought Kiva System. So Kiva Systems are essentially robots that pick up shelves in warehouses. So that completely changes how you, for example, would prepare an offer. And so there are challenges, for example, in inventory check or checking that inventory, inventory checks. So one application here is to look at computer vision and apply machine learning or statistical models to automate the process of inventory check. There are some other, of course, there's the Kindle, so there are lots of application in the domain of books. So for example, named entity recognition, identifying what are the entities on the page, relating them to other digital content, so try to enrich that content by, for example, to Wikipedia pages, or identify where an entity appears in the book, or for example, does he or she appear outside of that book, or does one specific location, which is real or virtual, where does that originates and where is that related? So it's very broad in terms of applications. In particular, in Berlin, we have, I mentioned algorithms. We did work a bit on recommendation systems, but like the main team is based in Seattle. So other teams, there is an NLP team, there's a vision team, and there's a demand forecasting team. So it's pretty broad.
It is very broad. So Mike Gualtieri in his talk outlined the process for delivering his next generation machine learning based applications. What does the data science lifecycle look like at your company? How mature are you? Are you following something similar, or how are you modeling? How do these models make their way into production? Lena?
I don't actually know if it's completely similar. I'd like to find out. So how it works for us, first of all, it's very dependent on the product. A lot of times we have projects which actually aim to find out if something works well. So then we develop it into a project, or it could actually be improve something existing like a recommendation engine. And oftentimes we do, on the analytical side, we do a prototype, we also implement it, we might even run the test, but it really highly depends on the team. We try to keep the teams independent, they can use their own stack, they have their own software, they have their own preferences, and then we run testing. And oftentimes it's still, there's still a gap between having this prototype and having it run successful to having it into production. Same as one guy earlier mentioned with his 5 years of Hadoop experiences, there's this gap. So we're trying to minimize this gap by actually now integrating the data scientists more into the team, also pairing them up oftentimes with developers from the start to make it as this transition as smooth as possible. Sometimes we solve it by the data scientist guys providing a library or providing a REST services, depending on the scale it needs to run. And then oftentimes it still needs to be re-implemented, but in a more scalable way. Also makes prototyping a little bit faster if you don't have to think about scalability from the beginning.
Do you have a sense for how much of, what's your things that you test to things that work ratio? Do you have a sense for that?
No. So actually we try to test in a way we test everything, at least with, we think before how we want to evaluate stuff. If you don't have a clear KPI or what you want to achieve with this product, it's usually not a good idea to just start off, oh, I want to try this new algorithm. You have to think about how you would measure if you were successful with your thing. So oftentimes we have that, even if it doesn't make it into a long-use product. So usually we do at least one test. If it's then not adapted by some internal stakeholder or someone who finds it interesting enough, then yeah, but at least one test is the minimum.
Great. Cedric, what does the process look like at Amazon?
So in terms of like developing like products with machine learning, so we try to, so there's a gap. I agree that it's like typically it's not easy to bridge the gap between, I would say, like more theory and computer science aspects. So what happens is that people develop, for example, like scientists develop like a prototype, and then they're really working together with the developers or the engineers to productize it. So it's really working hand in hand. They're typically part of the same team. So my team is half scientists and half researchers. So that's one way to try to bridge that gap. Another way is really what I was saying at the beginning, like trying to democratize ML, make it more accessible. Typically, we would like any maybe developer to be able to apply machine learning. And then the problem that remains is like, how do you frame that problem? So, and not have to worry about actual implementation details of a classifier. So having we have like a platform internally, which people can just call as a service to solve their specific business problem. And that's also what there was Amazon Machine Learning was launched a couple of months ago. That's a small subset of those tools that are available internally, and eventually they will be made available outside as well.
Great. So granted that the set of use cases that you're both attacking is very large, when we think about things like, let's say a personalization use case, what are you typically optimizing for? Are you looking at kind of expected metrics around revenue and click rates, profit, purchase rates, or are you thinking about ways to incorporate more strategic business goals or longer-term goals like customer lifetime value? How do those types is there a tension there between those? How do you deal with all that?
So we try to optimize for, there are a couple of metrics. It's typically, the first thing is like focus on the customer, so customer experience, like not breaking customer trust. So for example, in terms of personalization, we never look at specific data about individuals, but look at aggregated data. So that's one thing. In terms of the metrics, it depends really on what's there are different types of, for example, in the recommendation, different types of widget. Every widget is capturing like a different aspect of a recommendation, like people who bought this also bought this, or some recommendations from your history or from your wish list. And depending on the setting, we could optimize for like a conversion, like whether something was bought or not. Could be click rate, could be like also more like a customer experience, but that's typically very difficult to measure. So you have to find indirect ways, and that's not easy, I think.
Lena?
Finding a good KPI to measure is actually a really hard problem that's often underestimated. You need to think before you actually develop a problem like really hard on what you actually want to measure. Typically, in the beginning, people often start developing something, running a test, and then looking at all bunch of metrics. And then confused because usually some go up, some go down. So you really need to think before what you actually want to measure. And the longer term the goal is, like customer lifetime value, the more difficult it gets to measure, but also the more conflicting influence are on this metric. So let's say we run a test, and then also marketing does a big initiative and something else happens. So how will we ever know that this difference is actually attributable to us? And also how long we have to wait and how little data points we have. Because usually the further along you go with the KPI, the less data you get. If you go for sales, you have less than if you go for clicks and so on. So really take some time to think hard about your KPI, what you want to capture, pick 2 or 3, and then really go with those.
So it sounds like a big part of what you focus on is building a culture around data centricity around, managing to numbers? Are there other elements of the culture at your company that kind of lend itself to being successful with data science?
Yes, totally. So we have one value. They actually formalized on some values. They tried as we grew, because we grew very fast. We're 10,000 people now. So it's hard to get them all and agree on one mentality. So we have like this explicit values that we follow. And one is like what you can't measure doesn't exist. So really to install in every part of the company this idea that you have to think about what you want to achieve and you measure it. And then you can say, was this good or was it bad, what we did, what we decided. Another thing is kind of fun. So one value is we wear sneakers, not ties. So it's kind of contributing to this open idea. Also, purpose first, ego second. So if you have a really good idea, it doesn't matter if you're the lowest of the bottom, you can still pitch it. You can pitch it to someone who's 3 grades above you. Really makes it makes an open discussion very possible. If you think that we're going in the wrong direction, everyone is really open to saying, don't think that's what we're doing is a good way. Yes.
Does Amazon approach that similarly, or?
Well, to your initial question, I think the data aspect is still something that people should learn. Typically, they collect data for another. Not yet. They don't have the reflex to collect it for like a predictive task in the future. They happen to collect some data for some reason. So I think there's still that's a very big challenge. I think that will remain for a while before people start thinking more about how do they collect the data, and that it can really have an impact and can help automate some decisions. So there's still quite some work to be done there. I think on the metrics is also something which isn't typically the labels. It's like on specific tasks. It's something which is very costly to acquire. And is not always available. Like if you have documentation, you have some labeling, but in other tasks, it's not the case. Like image classification, you have to collect that information. And metrics are not so always easy to really measure without doing like user studies, and that's then not very scalable. So I think those are really additional challenges, like when you look at data science problems.
Okay. One of the things that we want to drill into is, big data, right? It's one of the key hashtags here at Data Natives. Where does big data really come into play for you, and what are some of the issues that it creates, and how do you get over those?
So for us, like big data, so some examples of big data is for, if you look at customer reviews, we have 14 years of like product reviews. So that's like a tremendous amount of text where you can do a lot of interesting stuff like summarization, like aggregation. Other examples are images about products. We have about 1 billion images of product images over more than 300 million products. So that's the typical type of scale that we're talking about. I think one thing that should not, I think a lot of the big data challenges are like in the pre-processing and feature extraction, and that's why Spark and Hadoop are so useful. You can often use like smaller. There are also some exceptions where you really need to scale up like algorithms and models. It does happen. There are models, for example, that could be very big, like a big logistic regression. You might need a parameter server because the model doesn't fit into memory, but those are really exceptions. Yeah.
Lena?
Yeah, I think one of the best kept secrets is probably that for a lot of the problems you don't necessarily need big data. So the algorithm itself, often you have to, if you have a big server, that's enough. But for the pre-processing, I very much agree with you. It's often nice and it's faster if you do the pre-processing in a distributed way, and you can spin up some machines. And it's just, distribution comes in a very natural way. If you code in a distributed way, you can scale it up, you can make it faster. But often we mostly need it for pre-processing, parallelly and fast. And then sometimes the algorithm also runs distributed, but oftentimes it's possible to have this part yeah, sort of locally on a big server. But pre-processing it's a lot of the task, and challenges that come with it. Me personally, I find it hard to debug, but also have not found a great solution for that. Because if you run and after 2 hours something happens, so yeah, it's definitely not as easy as if you can step through it and look at what happens with your data in the meantime. Yeah.
And does cloud provide any benefit there, or is that a part of the equation for dealing with big data?
We definitely use it a lot because it gives our teams autonomy. So if you have it on the cloud and you can have as much as you want for a given project, and you really can empower people. So for me, the part is a lot of the times empowering to the separate user and to the data scientist, because he can do it on their own. You don't have to every time go and buy an in-house cluster that is sometimes too small, and there are many people working on that. So it's kind of making the production cycle faster.
How does privacy come into play with that? Cedric, you mentioned keeping user identifiable data out of your modeling approach. Anything else you do there?
So I'm definitely not an expert in privacy, but yes, so for example, we do aggregate all the data that we cannot trace back to the individual, and we use, for example, the cloud, we use AWS internally as well, and so the
you
standards
don't use Google Cloud Engine?
No. So there's like a lot of, so I think the requirements are very, very high, the bar is very high to have like in terms of security and privacy, and so those are the standards that we use as well.
It is for us, it's also the case, and we are also listed on the stock market, so that means there's additional restrictions. We have to actually have to account for everything that happens on those servers. So we have developed our own like internal tooling. So first of all, everything runs in Europe, only on the Europe branch and data centers. We also use AWS a lot, and but also we have our own sort of images and stuff like that that make everything a step that runs on this cloud accountable, so we can trace what happens. We know what's what happens to the data, and we make sure it's safe and doesn't leave a certain geographic area.
Okay. Both of you have roles that involve consulting out to different aspects in your organization. What do you see as the path towards really democratizing, the term you used, democratizing machine learning and data science and making it accessible to the broader organization? First, maybe even a question before that, do you think that is, to what extent do you think that is the goal or required in order for the company to be successful? And then how do you do it?
So I think it's a response of like one thing that you can observe, that the people that have both like hands-on experience and know about like the details of, for example, machine learning algorithms is very limited. And so if you want to make that, like, that's not very scalable, and there's a lot of competition. So if you want to like have more applications that leverage the data, data-driven, I think that it's a good way of moving forward and making those, automating what can be automated. I think that even if you look at some like data scientists or like, for example, experts in NLP or computer vision, they may be developing new algorithms, but that's in some sense wasting, in some situation wasting their time. They know what that's classification problem, for example. They should not like think about how do I treat, like if I have like 1 billion images, how do I have to handle that? I mean, there should be a scalable way, like the service should on demand like be able to treat all those images without them to have to worry about infrastructure. I do think that so for example, if you have like even a simple logistic regression, well, you have a lot of data, you might use like stochastic gradient descent, you have to optimize a learning rate. Of course, people can do that, but it's wasteful. Like you have to run a couple of models, try to tweak which one's going well. That can be automated. There are some techniques that have been investigated recently. And I think it's very nice that in recent years, machine learning community has really looked into how do we really scale up machine learning algorithms? How do we start looking at distributed optimization? So that's very, very exciting to see. And so yeah, I think those things should be kept, like people should not be worried about those problems and focus on their business problem or application. Focus on, I don't know, the feature extraction, like how do you do the right representation of your data. I think that's probably the area where it's really difficult now to automate. You need to have like expertise in a specific domain to do the right transformation that will give you good predictive performances.
It seems like that brings up elements of design and usability, like how do we make these algorithms and techniques and processes more accessible to folks? Do you agree with that, Lena?
I actually would like to elaborate on the previous question a little bit. So I think it goes in both ways. The one thing that we do, we try to make data accessible and think a lot about, a lot of people could do good stuff with the data. Of course, you have to develop a good way for different people in the organization to access data and work with it in a safe and in good way that also takes into account privacy, but allow them to work with this data. A lot of the people have good ideas, so you have to enable them to actually access that and work with that. And if you have some data science product, also make them available internally, like you did with this the internal tooling that you provide. We also do similar things. For example, if we extracted features from images, this is accessible to, and a lot of the developers, engineers, they have great ideas, but they just don't have access to the data. So you might think about that. But also it's like, it will always require a little bit of consulting to the stakeholders. But would it be nice if people had this in mind? They would think about problems that they have in their business perspectives. Often they don't think about this a lot. Like, what data do we have? What problem do we have? Could I maybe ask someone to solve this for me? They know, okay, I can do it, but this mindset to think about, to make it known in the organization, that if you have a problem and maybe what kinds of problems can be low-hanging fruit actually.
So let me broaden my previous question about kind of design and usability and shift it to the end user perspective, right? So when you're dealing with these internal stakeholders, it's kind of this business-to-business relationship, but you're also dealing with these, relatively unsophisticated consumers that just want to buy stuff. And, to what extent do you have to actively think about, machine learning and machine learning not being spooky and creating these situations where, the ones we read about Target, telling the girl's father that she's pregnant or something like that because she looked at diapers or whatever. Does that come into play for you?
I think it's really important not to break the customer trust, and you have to be very careful about that. I think it's one way is to be transparent. I think really the user interaction is really super important. I think probably many companies or people don't really do enough of that. I think it's really important to have like, ultimately we like to have something which is continuously learning and improving over time. So we like to have human feedback. So with learning algorithms that have a human in the loop, you're capturing the feedback and you improve over time, but then you have to be careful not to become like too good at the predictions you make.
Anything to add to that, Lena? We're getting down on time. I'd like, as our last question, to get your thoughts on where you see the biggest opportunities for machine learning and big data and e-commerce over the next 12 months, and what do you see coming down the pike that you're really excited about?
So I think there was some recent progress, some so-called breakthrough on the deep learning front, which I think was, and there's not much new in terms of the methodology or really the algorithms. It's more like on the hardware, and I do believe that this will probably also have an impact on other types of models. So I'm looking for like hardware accelerations and how that can be used with specific algorithms to see what will be the impact of other algorithms in this family and other families. That's certainly one thing I'm interested in. Again, like one of the things I'm excited is like the core machine learning community started looking at more seriously at having guarantees and having look at new algorithms, how to scale them up, how to transform like traditional algorithms and make them distributed. And that's also pretty exciting, I think.
What are you pumped up about?
I'm actually interested in the same topic. So for us, it's also deep learning a lot. Like everything is image-based. So we already have some really nice commercial applications for data classification, data user data recommendations. But images is still like every time I use something, try to find something similar by an image, it's still not working well. But with the deep learning, it's getting there, and we're also experimenting heavily on that. So for example, to figure out if you have an image, where on the body are certain clothes, what makes a coherent outfit, stuff like that, we actually to recognize some of the stuff we sell in pictures, or maybe say, okay, you could combine that with it. So things like that is, I think image-based analytics will be big.
Great. Well, thank you both.
Thank you. Thanks a lot. Thank you.